Hello everyone, welcome back to my YouTube channel. The topic for today is going to be backtesting. And why I'm covering backtesting today, because in the previous video we have made a predicted model. What was that model? That was about the default, whether a person in the bank will default or not. And we calculated PD, LGD, EAD. Those are the component of basically estimated loss which we calculate for the credit risk portfolio, and I implemented mortgage. So the topic for today, as I said, is backtesting, because this is a kind of a model validation technique, and after this video you will not need any other video to understand backtesting end to end. And let me remind you guys, in a bank, if you're finding a job in analytics, okay, so back testing itself is a profile. There are teams, they are only working on back testing specifically, because back testing, what I will be explaining to you, this is a concept which can be applied in all the portfolio, like loans, cards, then you have mortgages, then you have auto loans, so many other portfolio like student loans, so many portfolios. Okay, so that's why there are separate team for back testing in all the bank, under credit risk also, under market risk also. So now, without wasting your time, let me take you forward, and please stay with me till the end of this video and you will leave with the full knowledge of back testing. On that note, let me take you forward. So as I mentioned, the topic for today is going to be model validation technique. And the technique name is backtesting. And guys, this is a super important concept if you want to work in a credit risk domain, or if you want to work in a financial sector bank or any other company in Bangalore, Hyderabad and Pune, because there is a separate team. I again mentioned this. Okay, now let's move on to the topic. So backtesting talks about, so there are two words if you see, backtesting. So when you calculate or when you compare, so when we perform the model validation, let me clear that first. Once your model development is completed and the model development team is saying that now our model is ready to be validated, then the model validation team comes. So at this step, when I am discussing all this with you, I am assuming that the model is fully developed. So now the backtesting, the purpose of backtesting is comparing predictions of your model with actual value. That's why it is known as backtesting, because you're going back with your predictions and you're comparing it with the actuals. Now let's say you build a model 1 year ago. So what are the predictions you did 1 year back? You will be comparing with the present and you will check like how many predictions were correct. So that process is known as backtesting. Okay. Now to perform backtesting, there are certain techniques which are usually followed. So backtesting is not just one technique based. So in backtesting you have multiple techniques. So the number one technique which is used is prediction versus actuals. The name of the technique is prediction versus actuals. Now what is prediction versus actual? Let's say I am working on a probability of default model for loan portfolio. So for loan portfolio, what bank want to know, like if we have, let's say 100 customer, so out of 100 how many will default, how many will non-default. So default is what? Like the people who stopped paying EMI. The non-default are, they are paying their EMI regularly. Obviously for bank, these customers are good. These are bad customer, default customer. Now using what is prediction? Now using prediction, what you will tell, let's say out of 100, you will say that 5 will default, 95 will not default. Now to calculate this, okay, what we do, we compare the predicted default rate with the actual observed default rate. Let's say this model, when this was built, when I said 1 year back, so let's say the model was built in 2024. Now I come to 2025. So over this whole 1 year, this model said that the default rate or percentage, it's same thing. Okay, so as I said, like 5 out of 100, so that is 5%. So default rate was 5% as per the model. So now the model validation team will check that what is the actual default rate in 2025. So that will tell you the actual whether the model is validated or not. So that difference between the default rate is actually going to tell you that how you are going to treat that model, whether that model is performing correctly or whether you need to do the changes in model, because model is not correcting the value prediction. So in that case, the accuracy of model is questionable. Now, how we do this comparison? So this is not an eyeball check, like I just see it and I am doing it. Okay, so for that I need to write a Python code. It will be a small Python code. So what is the library you will use for prediction versus actual? I will tell you the small code and I will execute the code also for you guys. So sklearn is a library in Python which we use here, dot matrix package. Okay, so from this we will import a very important matrix, that is confusion matrix. Now what is confusion matrix? I have covered it in the previous video also, but I'll give you a brief idea here also. Now sklearn matrix is the package and confusion underscore matrix is something which you will be importing in your code. Now I will use import NumPy because I will need the kind of array information in my code. So that's why I will use this library. After this, what I'll do, I'll just define two metrics. One is your predicted values, like let's say 1, 2 and 3. Then actual values, let's say 1, 2 and 2.5. So you can see the difference. Now using the confusion matrix, what I will calculate another variable, that is confusion matrix, that will be equal to, I will use this function which I defined up there, cm equal to confusion matrix, and inside this I will give actual comma predicted, and then I will print the confusion matrix. So this will give me a confusion matrix like this, 1, 2, 3, 4, let's say. So confusion matrix says this is your true positive value, the conditions which are true and prediction also true. Then you have false negative value, the value which are actually true but prediction says they are negative. Then you have false positive, the value is actually negative but the prediction says it's positive. Then this is the true negative. Like model also say this is negative and reality also say it's negative. So now let me take you forward and let me run the code which I already have in my Databricks environment. So you guys can see from sklearn.matrix import confusion matrix. This is a package. Again import numpy as np. Simulated predictions, that means like the predicted value, and actual outcomes, that is the actual value. Now this kind of calculation you can apply basically on any models, like which are your PD, LGD, EAD, any model. You can check the confusion matrix which will tell you about actuals versus predicted. Okay, now here we are doing that. Now in the confusion matrix calculation, I'm just creating a variable cm and then calling this function from here, and then actual value versus predicted value, and then print statement. And if I run this piece of code, so this ran quickly if you see in Databricks free community edition, because I don't need to import any sklearn or anything. That's why I love Databricks. Personally suggested, don't use Jupyter Notebook, use Databricks, because this is much better than that. Now this is the confusion matrix you have got. Like this is your true positive, then this is your false negative, this is your false positive, and this is your true negative. Now on the basis of confusion matrix, let me go back to our notes. Let me write our confusion matrix which we got as an answer here. So our confusion matrix says 2, 1, 1, 3. Now this one is known as type 1 error also, and we call it false positive. This 2 is true positive. This is known as type 2 error also, and this is also known as false negative. This is your true negative. So this was one matrix. Okay, now you can see how many true positive cases they have predicted correctly, how many true negative also they have corrected predictly. Now this is type 1 error, which is false positive. So this condition is a false positive case. Now this condition again false negative is the case. Now but you see the values are very less. If you take a total, 2 plus 1 is 3, 3 plus 3 is 6, and 7. Out of 7, 2 values are in the category where you can say those are errors, those are not the correct value. So now we need to calculate some more metrics over this confusion matrix, which will actually complete the back testing. So we are understanding the process of back testing. This is all part of back testing, calculating the confusion matrix. Now let's move forward. What are the other metrics we would be using? So the method which we use here is accuracy methods. Once we have the confusion matrix, we apply accuracy methods to the confusion matrix. Okay. Now what are the accuracy method? So number one matrix which we use there is itself accuracy. I will tell you how to calculate the accuracy. Then the second method which we use is precision. Then third matrix which we use is known as recall. And the fourth matrix is known as F-1 score. So on the basis of all these pointers, you will be able to predict the performance of your model. First, you check the predicted versus actual, that is your confusion matrix. Then you understand how many values TP, how many TN and FN and FP. Again, then you calculate the accuracy methods. So what are these methods? Accuracy basically talks about percentage of correct prediction. Percentages of correct predictions. Percentage of correct prediction means what? How many true predictions which are matching with the actuals are predicted by the model. That is known as the accuracy. Now how you calculate accuracy here? You will do the sum of true positive, which is 2, with the true negative, that is 3, and you will divide it with total, that is 2 plus 1 plus 1 plus 3, which is equal to 7. So here you will divide 5 by 7, which will come to somewhere 0.70, or we can say 71%. Now this is the accuracy of your model. Your model is up to 71% correctly predicting the value. Again, read accuracy is what? Accuracy, percentage of correct prediction. So this and this is the correct prediction, because true positive means actual positive and predicted positive. True negative means actually also they were negative, and prediction also says they are negative. So that is matching the value. Okay. Now this is accuracy. Then comes the precision. What precision says? Percentage of predictions that are correct. Now we will do this for positive cases. Okay. So precision, percentages of prediction that are correct. How I will calculate that? I will do TP, that is 3. Sorry, TP plus. So for precision, the formula, let me write the formula. TP, precision equal to TP divided by TP plus FP. that is coming 2, TP is 2, then what is TP again? You know 2 already, and what is FP? Where is FP? This, so that is 1. Again it will be 2 divided by 3. So if you divide 2 by 3, we'll get the percentage. Okay, so let me do that. So 3 divided by 2, so we'll add a point here, and then 6, and then 6, it will be 0.66 somewhere. So your percentage will be 66%, which is again a very fair percentage, not a very good percentage. Okay, so precision is not very amazing for this particular model. The accuracy was still better. Now we'll go to the recall. What is a recall? Recall is percentage of actual defaults that were predicted. Okay, now formula for this is going to be again TP plus Fn. So here it was Fp, here it is Fn, but in our case it is again same only. So 2 divided by 3, which will be again 66%. So recall is again 66%. Now let's move on to the F1 score. What is F1 score? Balance of, this talks about balance between precision and recall. So the formula of F1 is also using the value from precision and recall. Let me write the formula for you guys. Okay, so the formula for calculating the F1 score is going to be F1 equal to 2 multiply by precision multiply by recall divide by precision plus recall. So what we will do, 2 multiply by precision. What is the value of precision? You can say 0.66 multiply by 0.66, again divide by 0.66 plus 0.66. If you calculate this value, this is again going to be coming somewhere around 66%. I'm taking a round off, guys. Okay, now you can see the values. So this was the confusion matrix, which you can see up there, okay, which we have already discussed. Now as a model validator, when you are working in a team for a model validation, you will see that the accuracy is 71%, then your precision is 66%, then your recall is 66, and again F1 score is 66. Now what is your role? What you will say? So let me define it here. So accuracy is 71%, precision is 66%, recall is 66%, F1 score is 66%. Now on the basis of all this, you can say the accuracy of model is fair, good. This is not a very good accuracy, guys. Okay, now these values says this is just a fair model, but there is a scope of improvement. Scope of improvement. Now as a model validator, you will go back to the data, the initial data which was used by the model development team, and you will check on that data, and then you will suggest them that the accuracy of the model is this much, and the precision, recall and F1 score says that the model is very fair, so there is a scope of improvement. So I would suggest that you should use more training data to make your model perfect. Okay, so that's how the model validation or model monitoring team works. Okay, on that note, I hope you like this video. So if you like my efforts, so please hit the like button, please share this video with your friends and family, and please subscribe to my YouTube channel. Also, this particular sheet you will be able to download so that you have all the notes from my GitHub account, and the link of this workbook will be there in the description box. So on that note, I will take a leave from all of you guys. I hope you enjoyed the video, and keep supporting the way you guys support, and keep asking the question in the comment section. I will always reply to all the comments which are coming to me. Thank you.